Line postulate basically lets you construct a line between 2 points. Our line intersection postulate, don't worry too much about that one. That's just saying 2 lines intersect at a point. Our midpoint postulate says you can construct a midpoint. The angle bisector postulate says you can construct an angle bisector. So those top 3, these 3 right here are basically, they're the ones that allow you to draw something. So if you're doing a proof and you need to draw a straight line between 2 points, you need to draw an angle bisector, you need to draw a median, those are your go-to ones for drawing something. This parallel postulate, corresponding angle postulate, not as important. Not as important. This linear pair postulate is pretty important. That's a good postulate to know. That is, if 2 angles are a linear pair, then they are supplementary. Yes?
Can we just put star bounds that we think are...
You can do whatever you want. That is your sheet. I would strongly advise not crossing stuff out and putting huge marks that can't be erased, because eventually we'll get to all these theorems and postulates. But if I was you, I'd put maybe a little mark knowing which ones I'm going to and which ones are important. Reflexive and transitive postulate. These should have stars or something important by, because these will, no matter which section we're in, these can show up in the proofs. So we're talking about lines and angles right now. They show up in those proofs. When we get to parallel lines and transversals cutting it, these will be part of those proofs. When we get to triangles, these can be in those proofs. So these are kind of like, on the very first page, you have all those math ones that you can use as subtraction property. These are ones that might just appear without you realizing it. Most of the other ones, if we're talking about linear pairs, you already see it happening. You see a line and an angle. But these can appear in any proof all of a sudden. So those are just blanket proofs. No matter what we're talking about, these might be reasons for them. So those are big ones. Reflexive property, we haven't really used it yet, and we might not use it on a test, but all reflexive property says is something is equal to itself. Something is equal to itself. It's going to be more important when we get to triangles. But right now, just know that it's you are equal to yourself kind of thing. Transitive postulate, though, is pretty important. The transitive property, I always think of it like a train. It's a train of things happening that I want to show this is equal to the back end of the train by connecting everything together. So that is, if this is equal to that, and that is equal to this, then this is equal to this. All right, it's a train of statements. And it doesn't need to just be 2. You can go really far. You could say 1 is equal to 2, 2 is equal to 3, 3 is equal to 4, 4 is equal to 5, therefore 1 is equal to 5. Just make sure you have every step accounted for. That you went from 1 to 5 to show those 2 things are equal. The transitive property can a lot of times be used in conjunction with the substitution property. So there are a lot of times where you can use either one. Perpendicular postulates, just know them. Not going to be one of your major ones that you need to memorize or anything, but they could possibly show up. Segment addition postulate and angle addition postulates are always good ones to know. Those are always good ones to know. That's it for the postulates that will be on the test. All right, so all that triangle stuff won't be on it. Theorems, though. Let's go through the theorems that are going to be on it and what they mean. All right, theorem 1. If 2 angles form a linear pair, then those angles have a sum of 180. I'm going to draw a picture, and then we're going to talk about something. You absolutely can. The only thing you can't show is a full example where you're use it at this step of this proof so you have it. But any pictures or anything, did I miss something? What's happening? No fun. Stop. Stop. All right. So the theorem 1 lets me look at this picture and then go angle A plus angle B equals 180. It says the sum of both equal 180. So in a proof, that is, if they show you that picture, you are allowed to go measure of angle A plus measure of angle B equals 180 degrees. That's important for today's proofs. Yes?
So can write all that down.
Yeah. I promise you, I won't. You can write more down. The only thing you can't do is, like I said, you can't have like a proof off to the side that this is when to use this kind of thing. Before I move on, I do want to talk about, stick with this one because I'm going to show you the linear pair postulate and think about why they're different. This one says directly they equal 180 degrees. If you look at the postulate, very, very similar, except it uses the word supplementary. It's a small difference, but one's a little bit stronger at times than other ones. So they can both almost be used at the same time, but this one strictly says it's supplementary. This one gets me all the way to 180 degrees without having to know what supplementary means. All right, this one gets me to 180. So if the problem is trying to make it equal to 180, I would use this one. If your problem is just specifically saying show that these two things are supplementary, I would use the postulate. So if I'm using numbers, I'd use the theorem. If I just want to say that they're supplementary, I would use the postulate. Does that make sense? And both can be, I'm not going to take points off because you used the wrong one, but one's a little better than others in times. All right, theorem 2 says if two lines are perpendicular, then they form congruent adjacent angles. We are going to pretty much draw the same drawing for 2 and 3. So I'm just going to go ahead and draw it twice. And I'm going to cheat because I have an awesome copy-paste feature. So this first one says, if two lines are perpendicular, then they form congruent adjacent lines. So I'm going to go ahead and I'm going to name these lines T and L. So this theorem says, if T is perpendicular to L, bless you, then angle A is congruent to angle B. If two lines are perpendicular, then they have congruent adjacent angles. And in fact, what are the measures of those two angles then? Yeah, 180 degrees. So each one's going to be 90. All right, the next one. It almost looks the exact same. But you're going to look at it and it says it in a different order. It says if two lines form congruent adjacent angles, then the lines are perpendicular. So this is just the opposite direction of this one. This would be if angle A is congruent to angle B, then T is perpendicular to L. Theorem 4 says if two angles are vertical angles, then they are congruent. You should already have drawings on that one because we went through that one, right? We went through that one together. So you should already have a drawing. If not, just have two crossing lines where you have either side is congruent. If two angles are each supplementary to a congruent angle or the same angle, then they are congruent to each other. Kind of a drawing of that might be, let's go ahead and draw that. Let's go ahead and draw that. And then let's go ahead and draw that. And I'm going to label each one of these, let's just call them A, B, and C. So this would be set up something like if angle A and angle B are supplementary, and angle C and angle B are supplementary, then angle A is congruent to angle C. Does that make sense? Because all these theorems and all these postulates, you need to make sure that they make sense to you. It's really hard to prove something that you're just like, I don't even know why it's true. It's really hard to prove something. All right, so once again, this is basically saying if this is 100, and this is 80, and this is 100, and this is 80, these two must be congruent because they had to be the same angle for them to be supplementary to the same angle. And that's the only one we're going to go through on the theorems. So those are, right now, our primary postulates and theorems. But do not forget about the first page, which are all those algebra ones. You need to know all those. And all the definitions. All right, for postulate-wise and theorem-wise, that's all we're going to cover today. Do you see this theorem 5? This theorem 5 you could use on the homework tonight. I don't want you to use theorem 5 on the homework. All right, and you'll see it when you get to it. But do not use theorem 5 on this homework. You can use it in the future, but just for tonight's homework, you can't use theorem 5. I want you to do these kind of a different way. All right, we're going to do one of these together, and the rest are going to be up to you to do. So we're going to do theorem, or number 2, which is proving a theorem. Pay attention to this. You cannot use a theorem to prove itself. So if I'm asked to prove this, nowhere in these steps can I use this step. All right? It's like using a definition. It's like using the word to define a word. So you cannot use what you're trying to prove inside of it. So this says, if two lines are congruent, adjacent angles, then the lines are perpendicular. This is how I write proofs. I look at the end first. A lot of times I look at the end. And it says I want to prove those two lines are perpendicular. What does it mean for two lines to be perpendicular? What's that key thing that makes it perpendicular? Yeah?
They've got, in the middle, they're cut by a line.
They're cut by a line, but very specific.
Like, straight.
It is straight, but I'm looking for something a little more specific. They're not bisecting. Okay. They can. Remember, bisecting is just cut right in the middle. Perpendicular has, and if you're not sure, look at the definition of what it means to be a perpendicular line. There's one key thing I'm looking for. Yeah?
They intersect in 10 or 90 degrees.
I'm just looking for 90 degrees. So to be a perpendicular line, each angle needs to be 90 degrees. So what I'm thinking about right now is in order for these to be perpendicular, this needs to be 90 degrees. Because once I prove one of them are 90 degrees, all of them have to. All right, so I want to prove angle 1 is 90 degrees. Then I start thinking about, okay, I want to be in degrees. I want stuff that's in degrees. What do we know about angle 1 and 2 degree-wise? What do we know about angle 1 and 2 degree-wise?
They're supplementary.
They're supplementary. What does that mean in degree-wise?
Oh, they're both 90 degrees.
They're both what?
90 degrees.
Well, let's not make that leap yet.
Well, they both add up to 80.
They both add up to 180. This plus this equals 180. So is it that big of a leap to know that? Well, you already did it in your head, right?
Yeah.
You already made that leap that like, hey, I just need to go from 180, show that one of them equals 90, and then you're done. So that's this whole proof. It is these equal 180 because they're supplementary. Find a way to show that angle 1 equals 90 degrees or angle 2 equals 90 degrees, and then you're done. Just definition of perpendicular lines. As soon as I say one of these equals 90, you are done. This is not the only way to set up this proof. There's other ways. All right, but we're going to go through the way I have it set up, but it is exactly what I just said. We start with angle 1 equals angle 2 because that's given. All right, then we said angle 1 plus angle 2 equals 180. What theorem or postulate specifically says that two things equal 180 degrees. And we did talk about it today. What'd you get? Theorem 1. Look at it if you didn't find it. Theorem 1 says that linear angles equal 180 degrees in short. So our theorem 1 says that angle 1 plus angle 2 equals 180 degrees. That is our theorem 1. You might have used that linear pair postulate. I'd have been okay with that too. I'm just going to write theorem 1, or you could have used a linear pair postulate. Yeah?
I thought we were allowed to use like theorems.
You are allowed to use theorems. You cannot use the theorem that you're trying to prove. So I can't use this theorem and put it there. Because in fact, that'd be one step. And then I went one step further. I said you can't use theorem 5 on this homework. But after this, you're allowed to use it. So you can use anything as long as it's not this, the exact theorem you're trying to prove, or theorem 5. Is that clear? Okay. So like I said, there's multiple ways to do this one. But we're going to go ahead and just say angle 2 equals angle 1. What lets me replace angle 1 with angle 2? Yeah.
The right angle definition.
Probably not the right angle definition. It's not going to let me replace it. Replace usually means, yeah.
Congruence.
Kind of like congruence. I'm looking for something that specifically says I'm allowed to replace something. I can replace something as long as the two things are equal to each other. I can replace something as long as they're equal to each other. Sam, you got a second guess?
The commutative property.
Not quite the commutative, yeah.
Transitive.
Close. There's something way better, yeah.
Is it the reflexive property?
Not quite the reflexive. We're getting there.
Symmetric.
Not the symmetric property, Grant.
Associative property.
Not the associative property.
The
Substitution property.
Oh.
Substitution says you can substitute something in place as long as the two things are equal to each other. So this one needs to be our substitution property. This next step's pretty hard. Why you're allowed to do that next step is actually the distributive property. This is actually the distributive property. It's kind of like going backwards. Let me go ahead and put a slide up. Because if I would do 2 times a plus b, the distributive property says that would be 2a plus 2b. Well, the other direction is also still the distributive property. And if you look at angle 1 plus angle 1, it's kind of like doing this to, I should say, 1 angle 1 plus 1 angle 1. Kind of hard to see, but you're actually pulling that out front to equal angle 1 plus angle 1, which equals 2 angle 1. So that is the distributive property. All right, what did we do to get from 4 to 5? Remember, the key is what happened, and then what let you do that. All right, so that last step is definition of perpendicular lines. All right, the rest is on, oh, sorry, yeah, sorry.
I thought if you put a theorem, how are you supposed to prove it?
You don't, it's already been proven. So we're going to take every theorem as it's already been proved, or we kind of skip proving it.
Okay.
What I mean by it needs to be proved is it can be proved.
Okay.
Is it can be proved. Postulate's not, you can't always prove a postulate, so we just take it on faith. We take it on faith that it's true. There's no real proof. A lot of geometry is based upon these postulates that we use then to prove the theorems. So we take these things on faith to prove bigger things. All right, so a theorem is something I can prove. We're not going to always prove them. If you look at the homework, we are proving several of the theorems in it. That is pretty much the bulk of this homework. But as long as you are not using the theorem you're trying to prove, you're allowed to use anything except for theorem 5 in these. Okay? Yeah. Yeah. Other questions? Okay, the rest of this is homework. I do want to note that number 1 is fill in the blank. 3 and 4, I left off the statements, so you are completely pretty much filling out the proofs. 5 and 6, you have to even draw your columns. You have to even draw your columns. Yeah.
Would for number 1, would the reason not be the given because it doesn't add the forming angle 1?
It would still be given, if you're pulling any part from the given. In fact, everyone look at number 4. Look at number 4. Do you see how much stuff's given? So technically, you'd have to write all of that out. A shortcut in that is just put as listed above. That way you don't have to rewrite the entire big. So sometimes when there's a ton of stuff, just put as listed above or C above, and then just write given. That way you're not rewriting all of that for the sake of rewriting it. All right, go ahead and get started. I strongly encourage you work within your pods, or work with someone in your pod, or work with all 3 people in the pod. The more brains, the better. Ask tons of questions.